Okay, properties of parallelograms. Parallelogram opposite sides theorem says that if you have a parallelogram, then the opposite sides are equal. Okay, so that does not mean that PQ is equal to QR. Opposite sides are equal. So QR is equal to PS. Parallelogram opposite angles theorem. So this is important. It's a four-sided figure, so we learned yesterday that four-sided figure, the interior angles equal 360 degrees. So if they equal 360 degrees, then these two are the same, and those two are the same. Okay, what does that mean? It just means that these two are supplementary, and those two are supplementary, those two are supplementary, and those two are supplementary. Okay, which we get to the parallelogram consecutive angles theorem. So if a quadrilateral is a parallelogram, then it is consecutive angles supplementary, okay? So x and y add up to 180. So these two add up to 180, those two add up to 180, those two add up to 180, and those two add up to 180. Parallelogram diagonals theorem. If you have a parallelogram, then the diagonals bisect each other. All right, let's get started. Find the exact value of each variable in the parallelogram. Okay, well, x equals 9 if it's a parallelogram, and y equals 15. Let's start out easy. Number 2, n equals 10, and m plus 1 equals 5. So we subtract 1, and m equals 4. Okay, so now we have angles here. These two are the same. D minus 21 is equal to 105. So we add 21, and D equals 126. Okay, and then we have side lengths. They're equal. 20 equals z minus 8. So we add 8. And 28 equals z. All right, number 4, the same type of thing. The two diagonal angles are equal. So g plus 4 is equal to 63. We subtract 4. G equals 59. And then our sides are equal. 7 equals 16 minus h. So now we're going to subtract 16, but don't forget, don't drop that negative sign. So this is negative 9 equals negative h, or positive h equals positive 9. Okay, so find the measure of the indicated angle in the parallelogram. Okay, so we want angle B, which is this angle right here. So remember, these are supplementary. So 180 minus 51 gives me 129 degrees. That would be angle B. Angle N is this angle right here. So these two are supplementary. So 180 minus 95 is equal to 85 degrees. Find the indicated measure in LMNQ. Okay, so LM is the same as 13. LQ is the same as MN, 8. LP, now these are diagonals, so that means they bisect each other. So those two are the same. So LP is the same as 7. MQ is the long diagonal. So if this is 8.2, then this piece has to be 8.2. And MQ would be those two added together. So 16.4. LMN, the angle, LMN here. All right, so I'm going to stop this and I'm going to erase these marks and start over. Okay, the angle LMN is that angle. Okay, it should be the same as this angle here. Okay, those two angles are the same. Well, I don't know what they are, and the 29 degrees, this is the diagonal is not a bisector. It's only a bisector in a rectangle and a square. So you can't say that this is 29 here. Okay, so don't do that. But this angle here, angle LQN, is supplementary to this angle. Okay, and this angle, which is the one we're talking about, is supplementary to this angle. Okay, so these two are supplementary to each other. If that one's 100, then that means LMN is 80. MNQ, all right, so now we know that this is 80 degrees. That's 100, and the corners are, the diagonals point to the same degrees, so this is 80. And if at angle L, that whole thing is at 100, then this is 100, which is what we are asking here. MNQ is 100 degrees. Now, NQL, this big angle right here. Well, we already figured that out. That whole thing is 80. And then it says LMQ. This angle right here. Well, this is parallel to this one cut by a transversal. So we have alternate interior angles. So if that's 29, that one's 29 degrees. Okay, find the value of each variable. All right, so now we got to find M and N. So these two are the same. Diagonal angles are the same. So 2M equals 72. Divide off the 2, and M equals 36. And if this is 72, it's supplementary with that angle. Okay, so that means 180 minus 72 would be angle N. So N equals 108. Number 16. These two are the same, but there's two variables. I can't figure that out. These two are the same, but that's two variables. I can't figure that out. But these two have the same variable, and they're supplementary. So I can do B minus 10. Supplementary means that two angles added together equal 180. So B plus B is 2B, and I got a negative 10 and a positive 10. They cancel out. So I divide off the 2, and B is 90. So if B is 90, I can substitute it into both these positions and figure out some things. So if I do this first one here, 90 minus 10 is 80. So this is 80 degrees, which makes C 80 degrees. And C and D are supplementary, so that means D has to be 100 degrees. All right, so now we have diagonals. Remember in parallelograms, diagonals bisect each other. So the K plus 4 is equal to 11. So subtract 4 and you get K is equal to 7. And M is equal to 8. Okay, number 18. Again, these two are the same. So V over 3 is equal to 6. So multiply by 3. And V equals 18. And these two are the same. 2U plus 2 is equal to 5U minus 10. So I'm going to subtract 2U. And I get 2 equals 3U minus 10. Add 10. I get 12 equals 3U. And divide off the 3. U equals 4. Now, what did they do wrong here? We have a parallelogram. And it says, because quadrilateral STUV is a parallelogram, angle S is congruent to angle V. They're saying that these two are congruent. Well, just look at this. This is acute, and this one is obtuse. Obviously, they're not the same. So, based on what we are seeing here, the measure of angle V is supplementary, which makes it 180 minus 50 is 130 degrees. Okay. What did they do wrong in this one? Let's read what they said. The parallelogram GF is congruent to FH. They're saying that GF is congruent to FH. Well, that's not true. Only in a square and a rectangle would that be the case. So GF is congruent to FJ, and KF is congruent to FH. Okay, so we have a proof to do here. So we have our given that those two are parallelograms. All right, so then we can say that AB is congruent to DC, and you can say that DC is congruent to FE, and the reason for those is parallelograms, let's just do this, parallelograms, opposite sides theorem. Okay, opposite sides theorem says they're congruent. Opposite sides are congruent. So AB is to CD and CD is to FE. So therefore, you can say AB is congruent to FE. And that would be the transitive property. Done. Okay, now we're going to graph. Okay, so let's just draw a graph here. And let's see, the highest numbers on number 23 are 5s. So we'll just use these large boxes for numbers. So negative 2, 5. So 1, 2, 1, 2, 3, 4, and 5. So there's negative 2, 5 for W. 2, 5, 1, 2, 2, 5 is X. And 4, 0, 3, 4 is Y. And 0, 0 is Z. Okay, so what are we doing here? Let's connect them. Let's just change colors here. Let's do blue. All right, so there's our parallelogram. It says, find the coordinates of the intersection of the diagonals. Okay, so we need to connect the diagonals here. And let's see if we can do a fairly straight job and see if we can get lucky here and see what they are. Okay, so to me, this is probably not meeting at a nice, neat point. Looks like it's going to be at 1 and 2.5. So that could be 1 and 2.5 or 5 halves where they meet. And a quick check of the answer key, and that's correct. 1 and 5 halves. Okay, so let's do the next one. You have to draw your lines straight. So on the test, just use a ruler or the, I don't know, some straightedge that you have. Okay, so this one, again, the numbers are 5s or less, so we can just use the big boxes. Negative 1, 3, negative 1, 1, 2, 3, there. And 5, 2, 1, 2, 3, 4, 5, 2. So this is Q, this is R. And 1, negative 2, 1, 2. That's S. And negative 5, 1, 2, 3, 4, 5. Negative 5, negative 1 would be T. So let's draw as straight a line as we can. And try to draw, let's see if we can just use a straight line here. Oops. All right, so I'm going to go from here to there. And that's pretty close to it. I can move it if I need to, and do the same thing on this one. Okay. All right, so now I'm just going to grab it and see if I can just grab that one. Come on. I guess it won't let me. Oh, this one's there. All right, so look at where this one is. If we highlight that, that looks like it's at 0, 1/2, 0.5. And let's look at the answer and make sure it's right. And that is correct. So when you're doing this, make sure you use a straight edge and make sure it's highly accurate. All right, now they're giving you 3 vertices. You got to find the 4th. So let's draw this. Trying to draw these as accurate as possible. 0, 2. We'll put here for D. Negative 1, 5. 1, 2, 3, 4, 5. Negative 1, 5 is E. And G is at 4, 0. 1, 2, 3, 4. All right, so where is the third possibility? So let's just draw this one in black. If these two lines are part of it, then we just use slope. All right, so the slope from E to D goes down 1, 2, 3, and over 1. So go backwards from G, go up 3. 1, 2, 3, and left 1. So that would be at 3, 3. That could be a possibility there. All right, so we'll connect that. And then I'm going to do the next one in blue. Let's say, instead of going E to D, let's go E to G, okay, and G to D. So that means going from G to D, or G to E, excuse me, what's that slope? Goes down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. So down 5 and over 5. So from D, let's go up 5 and over 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Way over there. So if we connect that, you have another possible parallelogram over there. Okay, so crazy stuff. So that would be at D. We went up 5 and over 5. So 1, 2, 3, 4, 5. So that's at negative 5. And up 1, 2, 3, 4, 5, 6, 7. So negative 5, 7 is the other possibility. So because this is telling you to do it in a certain order, DE, you got to follow the first one. It goes D to E, okay, and then E to F, and F to G, and then G goes back to D. So I know these two have to be like this based on the order they gave. So I know this one up here is not going to be the answer. So 3, 3 is the answer. So all you have to do, so you don't have to get confused, is use that as a guide. Use the order as a guide. All right, so let's do it again. All right. So we have more room here. We can go use the big boxes here as a possibility. Okay, so let's do negative 2, negative 4, negative 2, negative 4. That's D. Okay, and again, it's D, E, F, G. All right, F is at 0, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so it doesn't go from D to F, so don't do that. And then G's at 1, 0. Okay, that's G. Now it does go F to G. And from F to G, G goes back to D. So I know this is the shape of one side. So what you're going to do is, to go from D up to this point, you need the slope from F to G. All right, so let's get that slope. And down 5, down 7, and over 1. Okay, so that's negative 7 over 1. So from D, let's go up 7. 1, 2, 3, 4, 5, 6, 7, and left 1. That would be where E is at. Okay, so what is that? 1, 2, 3, and up 1, 2, 3. Negative 3, 3. All right, same thing again. Wow, that was so not straight. Negative 4, negative 2. 1, 2, 3, 4. 1, 2. There's your D. From D do we go to E at negative 3, 1. F is at 3, 3. 1, 2, 3. 1, 2, 3. All right, so D to E to F. So now we know that G has to be over here somewhere. So we use the slope from E to F to match to going from D to G. So E to F, the slope is up 1, 2, and over 1, 2, 3, 4, 5, 6. So from D, we're going to go up 2, 1, 2, and over 6, 1, 2, 3, 4, 5, 6. So there is G at 2, 0. All right, last one. Negative 1, 4. 1, 2, 3, 4. That's E. And again, F is next. 5, 6. 1, 2, 3, 4, 5. 5, 6. So 5, 6 is F. They are connected, E to F. And then F to G, 8, 0. 6, 7, 8. Okay, so F to G. So to get D, let's use our slope from F to G so we can figure out where D is here. So F to G, we go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So from E, we should go down 6. 1, 2, 3, 4, 5, 6, and over 3. 1, 2, 3. So that should be D. And if we connect them, it sure does look right. So that's at 2, negative 2. And that's it. Good job.